Today we're talking about augmented matrices and systems. So we talked a little bit about in 4.7 about how to solve matrices using matrices and Cramer's rule. But today we're going to talk about row reduction. So first we're going to talk about an augmented matrix. So an augmented matrix is when you take all of the coefficients of the system and then tack on at the farthest right column, you tack on the constants. So the leading entry of a row is in a non-zero row of a matrix. The first non-zero entry is called the leading entry. And you also have leading zeros. The zeros before the leading entry of a row are named leading zero entries. I'm not going to read what is meant by echelon form. We're going to use a calculator. If you want to read it, you're more than welcome to, but I'm not going to read it to you. Really, our goal when we get in row echelon form or echelon form is you have 1 0 0 0 1 0 0 0 1 tacked on with some variables we'll just call x1, 2, and 3. And that's how you'll find your x, y, and z in this case, or your x1, 2, and 3. Also, I'm not going to read to you what really a reduced echelon form is, because once again, we will use a calculator. So, we are going to write this equation in augmented matrix form. So this equation I just moved down here because it's extra. It was supposed to be down there, but I forgot to hit enter. So, in our matrix, we're going to have a column for x1, column for x2, column for x3, and a column for x4, and then a column for k, which will be our constant. And always draw a little dashed line here so we know the separation between the equation and the constant. So for this, we have x1, 1, -1, 2. They don't have any in the fourth equation. x2s, we have 0, 1, 0, 0. x3, we have 1, 0, -5, and 1. And x4, we have -1, 2, 3, and -1. And our constants, we have 8, 5, 3, and 7. So that's how you write it as an augmented matrix. So to solve this system by reducing the augmented matrix to reduced echelon form, we have to first write it in an augmented matrix. So let's do that. We're going to have a row for x1, a row for x2, a row for x3, and a constant column. I just called those all rows and meant to call them columns. So we want 1, 2, and 3, -1, 1, and -2, 2, -1, and 4. Then we have 5, -3, and 9. So now we are going to use this matrix here in our calculator. So let me pull up my calculator. All right, so on your calculator, you are going to go second matrix. And you're going to go over to edit. You're going to type in a 3x3 matrix. Maybe. Edit. Okay, so it says to create matrices alpha zoom for me. You will just create it like normal. You have 3 rows. Oops, alpha zoom. And 4 columns. And hit OK. Oops, that's a mess. Okay, so second matrix over here, alpha zoom. Hit OK. Okay, so now I can type it in. 1, -1, 2, 5, 2, 1, -1, -3, 3, -2, 4, and 9. All right, so that is matrix A. So I'm going to store that in matrix A. Hit enter. Okay, well, I'm going to take this matrix here, go to second matrix, go to math with matrices, go down, nope, not over, down, so you find the one that says RREF. So we're going to do RREF. Maybe. This doesn't want to cooperate. We're going to RREF. Helps if I read directions, maybe. RREF matrix A. So that of matrix A, wherever A went. It should be at the top, right? Well, it didn't work, but it should have worked on your calculator. So I should do it. So we're going to go to, I'll write the steps out. So you're going to go to matrix, type it in, it's a 3 by 4, 3 rows, 4 columns. 1, -1, 2, 5, 2, 1, -1, -3, 3, -2, 4, and 9. Then you're going to go to matrix, back to matrix, quit out of it, choose over to math, choose RREF. So that's reduced row echelon form if you really want to know, or B on your calculator. And you're going to RREF matrix A. And you will get you'll get 1, 0, 0, 0, 1, 0, 0, 0, 1. Look, that's what we wanted before, -1, 4, and 5. So what that tells me is x1 equals -1, x2 equals 4, and x3 equals 5. Or you have an ordered triple of -1, 4, and 5. And we won't worry so much about ordered triples. But that would be your solution to your system.